Hi, we're in Lean Six Sigma Yellow Belt control phase, the last of the 5 phases to make: define, measure, analyze, improve, control. So we've made improvements. How do we make sure that the improvements that we made end up with the results that we're looking for? So we had these potential improvements with potential impact. You might see that we're trying to quantify to a great extent. Instead of saying improve on-time delivery, and then we're saying, okay, we're reducing shortages by a certain number, or we're reducing inventory by a certain number. So we try to quantify the potential impact. And did we achieve the improvements that we planned on? Notice the one right at the very bottom, reduce price, and the potential impact is to reduce cost. Well, duh, if you reduce price, you reduce cost. Well, not necessarily. We may reduce price by using a vendor whose quality is poor, and we end up spending more money somewhere else and actually increase the cost. So can we validate that we've made the improvements that we intended to make? And then we implement process controls. One of my favorite management tools, and it's broader than in a lot of tools, is 5S. It comes from 5 Japanese words that start with the letter S. And it's been variously translated into 5 English words that start with the letter S. And here's at least one set of those. Sometimes you'll see, by the way, 6S with safety as the 6th S. Some may have some other S's, but if I were going to do 6, it would have safety in there. So the first 3 are really separate, and quite often you'll find literature talking about 3S. They're talking about these first 3, because this is what happens on the floor. The second, or the 4th and 5th S's, are how do we make sure that the first 3 S's actually happen. So it's a tool for maintaining shop floor or office discipline, that we're organized, we stay organized, we're focused, and we stay that way. So here's sort of organize by getting rid of what you don't need, and so you only have that, and then you put in order what you have left, which is essential. You've already defined it as essential. And then the shine has to do that we maintain a discipline to make sure that entropy doesn't happen, and we end up needing to sort again. We standardize. We're getting more at the supervision and management levels with standard operating procedures for the 3S above, and sustain is like the top level management, and that has to do with audits, and again, get out and look, get out and listen, get out and learn, get out and lead. You have to show that you mean it. I was in a Walmart distribution center, the one down near Shelbyville, and Dr. Cliff and I were taking a tour, and as we were walking across this distribution center, which is like a giant refrigerator, basically, I noticed a big shard of wood. It was a pallet had come apart, and here was this huge splinter. I mean, it was probably 2.5 feet long. And here's the distribution center manager, the top guy. And I thought, what is he going to do with this when he gets to it? And he made a beeline for that, and then he picked it up, and he looked back and forth, and he saw the nearest trash can, and he went over there and he put it in the trash can. Didn't say anything to us, just kept on going. I thought there was another employee along with us, and I thought the top guy just emphasized that the 3 S's were important to him. A little bit later on, he picked up another piece, but this time instead of taking it in the trash can, he kept on the tour holding it. And when he got to another employee and was asking them something, he just handed them that fragment of a pallet for that person to dispose of. Again, making sure that the lesson got in, that I'm seeing this and it matters. So just an incredibly powerful tool. Another powerful tool in control, and really the one we'll focus on is control charts. In control charts, we're distinguishing between random variations and some sort of special causes. There are different types of control charts. If we have variable data, which is just any type of physical attribute that we're measuring, then we use two different control charts. We use X bar and R charts. X bar charts are looking at a plot of averages. That's what the X bar really means. It's an X with a bar over it means average. And so we're looking at, that gives us a central tendency. How close is our process to being centered to its target? And then R is stands for range. Range is just smallest minus largest, and that's a measure of variation. It's not standard deviation, but it's a way to sort of estimate standard deviation and get at it without much math. So we get both. We get how close are you to centered, and how spread out are you with using these two. If you have attribute data, this is defective, not defective, present, absent, good, bad, then you have a choice of charts. The most common one is a P chart, which is a proportion defective. And I won't go into the rest of these. So when we're plotting these different statistics over time, then we'll end up with this normal distribution. We'll end up, if we're plotting averages, we will end up with a normal distribution regardless of the parent population. The parent population might not be normally distributed at all, but the central limit theorem teaches basically if we have enough samples of averages, then the distribution of the averages will be normally distributed, even though the parent population is not normally distributed, which is very convenient for us. The upper control limit and lower control limit are basically plus and minus 3 standard deviations. Usually, some companies choose others, that's the standard. It's plus or minus 3. That's not 6 sigma, that's 3 sigma, plus or minus 3 standard deviations. And that means that there's going to be some events that are going to be outside that. So we plot these averages, these statistics, which are usually averages, and if they're in control and capable, then all of them will be inside the control limits. But if we have a single sample statistic that falls outside the control limits, then the process is considered to be out of control, that's the technical term, and it's unstable or unpredictable. We can't tell for sure where it's going. There is still a possibility of making an error because there's a little bit that falls out. Even if we have perfectly centered, there's still I believe it's 3%, something like that, that falls outside of the plus or minus 3 standard deviations. So remember, these are averages, and our tolerances, our specifications, are not based on average, they're based on individuals. So this is not saying that you're good or bad. Can't say that. This is just saying, are you predictable or not? Control limits are generally plus or minus 3 standard deviations, not always. I think I must have skipped one. I do want to make the point. If all of your points are inside the control limits, normally we say you're in control. There are exceptions to that, several exceptions. I'd say like 7 exceptions at least. So if you have a number that are all on either side of the mean in a row, if you think about it and flipping a coin, it's a 50% chance that the next one's going to be above or below. And then 50% chance that the next one's going to be above or below. At some point, just a non-parametric statistic would say that if I have so many above the mean in a row, that's not chance anymore. Something's happened. So there are other rules, but we're going to focus on, is it inside the limits or not inside the limits? Control limits are based on what the process can do, not what you need or require. Control limits indicate stability and predictability, not good or bad. And 6 sigma is plus or minus 6 standard deviations, not plus or minus 3 standard deviations. So even though we use statistical process control, which is what we use control charts, in Six Sigma, they are not Six Sigma in and of themselves. We're going to mistake proof where possible. Again, this is a control. This could be an improve feature, but it could also be a control tool as well. And we're going to complete project documentation. So what do we mean by that? Control plans, usually associated with control charts, or with failure modes and effects analysis, that right side of failure modes and effects analysis. Audit plans, which could be related to control charts, could be related to failure modes and effects analysis, could be related to 5S. Training plans. Wow, a lot to say there, and I won't go into detail, but quite often we can develop a good process and then we don't train, and they're not going to do it. And then documentation plans. And other forms of project documentation, standard operating procedures, we talked about those in 5S. Work instructions, and these can be visual, that would be best. Lessons learned, so when we do the next project we can do better, and a final report on the project. And that is our control phase.